So in this lecture, I want to look at the history of a movement that sprung up in the 60s, 70s, and 80s that looked around at the industrialization of building components and also at the sort of unbelievable successes that technology had in what we might call the space age, right? When people are being sent to the moon for the first time. There are advances in aviation, advances in automotive technology, nuclear energy, polio vaccines, things like this. There's an optimism about not only the achievements of technology, but also the pace of technology, and the idea that a lot of the issues that had faced builders especially, but also cities, just humans in general, before World War II were being solved, and that a lot of these were being solved in architectural or constructive scenarios. The so-called high-tech movement, that's a label that none of its practitioners really accepted, is one where architects and designers are looking around them and finding in the advances themselves, in the advances in building technology themselves, new vocabulary, but also a kind of new language, right? A new way to express the goings on of a building, right? The things that maybe make it work. High tech is both a kind of cultural movement, right? You can see it as a sort of stylistic thing where technology gets accepted as the aesthetic basis for not only architecture, but also a lot of art forms. But it also, of course, like many of the movements we've seen, has an economic base, that if you're using raw things from the factory and not spending so much on polishing them, your buildings maybe end up a little cheaper. As we'll see, that is not universal, but that is part of the argument for high tech, is that by using the technology kind of off the shelf, or by hewing very closely to the principles of structure and fabrication and environmental control and things like this, that there are savings potentially to be made, or at least conceptually. A lot of the high-tech generation grows up in England after World War II, and there is a real sense in British education that science in particular is a topic that in many ways sort of rescued the country during World War II. There's a lot of emphasis on the fact that British engineering, things like the Spitfire or the Lancaster bomber, these were critical in Britain's defense of itself and in the Allies actually winning World War II. And so there's a commitment to really intensive science education, but also a kind of culture of science, TV shows, magazines, things like that aimed at kids that really glorify science and the achievements of technology. At the same time, industrialized building sort of goes mainstream. All of the housing that has to be built, not only in Britain, but throughout Europe after World War II, is really a testing ground for the industrialization of construction. And this, by the late 50s, early 60s, gets to a point where it's kind of accepted as part of the landscape, but also where it's really matured. And along with that, we see the advances in structural engineering that lead to the sort of larger and taller towers, longer spans for things like aircraft hangars and sports arenas, also becoming mainstream. There is this broad interest in expressive technology, especially when the space program in the United States really gets going, and these missions are televised. People see firsthand on TV screens themselves a major technological innovation, the advances that are being made, and wanting in some ways a kind of piece of that. And then finally, one of the really crucial things that comes in during this period is the first episodes of what we might call computer-aided design. Very, very crude and kind of raw compared with today's CAD, of course. But nevertheless, substantial beginning efforts are made at using the computer to help design and to help manufacture, but also to optimize design and construction. The three figures who are usually associated with this movement, two British architects and one Anglo-Italian architect, Richard Rogers on the left, Renzo Piano in the middle, and Norman Foster on the right. These are the kind of troika of quote-unquote Anglo-Italian high-tech, and certainly their careers are the kind of broadest examples of these, of the confluence of these influences. We'll look at each one of the three, but I also want to talk about the kind of broader movement a little bit, both the spin-offs, careers that came out of, in some cases, some of these offices, but also reactions to the sort of glorification of technology, especially in the 60s and 70s after 1968. So we have seen all three of these before. In the lecture on Kahn, we talked about the fact that Kahn is seen as many things, but one of them is clearly the kind of godfather of the high-tech movement. We looked, for example, at Norman Foster and Richard Rogers' thesis project that they did together in the master's program at Yale after Kahn had stopped teaching there, but their studios, as you can see here, that is Norman Foster sitting on his desk in the Yale Art Gallery, designed by Lou Kahn. And you can see that Rogers and Foster's thesis project really draws on Kahn's idea about not only expressive structure that he worked on with Auguste Commandant, but also finding a language for the mechanical systems, in this case of a science complex with lots of laboratories and therefore lots of laboratory exhaust. Foster and Rogers returned to England. Rogers' family is both Italian and British, and it comes from a considerable amount of money. And they do the traditional thing, which is design a vacation house for Rogers' parents in Cornwall. The Creek Veen House is kind of fundamental, sort of the origin story of an office called Team 4 that Norman and his wife Wendy Foster opened with Richard and his wife Sue Rogers. The house is a fairly standard issue, kind of mid-60s house, but with exposed construction materials, especially exposed concrete masonry units or concrete blocks. And as you can see, ideas about using glazing for skylights, exposed registers for HVAC, things like that, built into the landscape in a way that was very common. But in many ways, a kind of very good but sort of standard issue late modernist house. They get commissions, though, increasingly from corporate clients wanting them to do industrial work. And they kind of revel in the challenges of building factory buildings that have open spans, doing them really, really inexpensively, but also finding ways to develop a language that suits the type of fabrication going on. Reliance Controls is an electronics company, so they're making pretty high-tech stuff. Like most good factories, even going back to Albert Kahn's factories for Henry Ford, they need a lot of open space so that they can plan the production process most efficiently. And they have a couple of different types of space that they need to enclose, so offices, lounges, things like that. And you can see on the right a perspective done by Team 4, and in the plan that there is a sort of Misesian sensibility to this. Steel being used kind of off of or fresh off of the rolling mill. You can see that there are welded torque boxes that you might remember from discussion of Fosler-Kahn, and all of this is exposed, right? It is expressed. There is a kind of frankness about the materials going on here. But there's also a series of refinements that I think take them from sort of being just Mies disciples into really looking for a slightly more articulate language. On the left, you can see on the exterior, there's a water tower that probably reminds you of the Smithsons at the Huntington School. And on the right, you can see a very, at what at first glance looks like a very Misesian detail, but in fact, I think is a little bit more articulate and a little bit more honest about the way that the building was actually constructed. You can see that the building has its lateral bracing outside on the exterior. The cross bracing becomes part of the kind of ornament or part of the aesthetic of the building. And on the right, you can see that there's a layering that Mies would never have done, right? Mies would have made sure that all of these joints were kind of smoothly fared into one another. There wouldn't be anything sort of sticking out, and there certainly wouldn't be things stacked on top of one another. But the argument here, or the rhetoric here, is that it's not only a structure, but it's also a thing that is assembled. And so there are clues in the detailing to the process and also to the sequence for how the building is put together. You can see that the giant kind of portal framing that includes the torque box, clearly that goes first. And the purlins, which are shorter spans, go on top of that instead of being fared into it as Mies might have done. On top of those purlins is the roof deck. So there's a kind of taking apart or a detailing it so that you see each individual system or each individual element and also get a sense for the sequence in which they must have been assembled. That is more expressive of the process than Mies's architecture was, but it also has with it the kind of rhetoric of, again, what often gets called like material honesty or structural honesty. I would call it more frankness, right? Accepting what the materials are like kind of off the shelf, putting them together in thoughtful ways, detailing them in thoughtful ways to clarify or to sort of choose which expression or not. But in the end, letting the materials kind of speak more or less on their own, right? And the kind of raw rolled steel that you see here is accepted for its thin edges and just simply painted, right? Nothing. There's no sense that they're trying to hide anything. So while this is going on, in Italy, Renzo Piano, who is the son of a family of builders, of contractors, Piano comes up through his family's firm, and he wins a scholarship in the 1960s to go work for Lou Kahn's office. And we looked at the drawings that he did for an alternative arrangement for this Olivetti factory in Harrisburg. He's only there 6 months. This seems to be the only major project that he takes on. But you can see that he's interested in lightweight structures, and he's interested in this case in looking at materials like fabric and in the end, like plastic. This was a scheme to do a plastic roof instead of the concrete parasols that ended up being the structural roof for Olivetti. All of these are done with an eye toward both how these would be made, but you can see also how they would be put together. A lot of details about fittings, about sequencing, about how things get bolted together in a way that you can imagine the son of a contracting family would be both familiar with and maybe also fascinated by. Piano gets a couple of initial commissions. This is on the left, a shed for a sulfur factory that he designs as a folded plate arched system. So you can see the geometry there, sort of the origami of the folded plate is going to give it some depth and some stiffness while keeping the roof itself very thin. And on the right, you see experiments that Piano did on his own, building on the idea of space frames and how some of these plastic elements that he had conceived for Olivetti might be used in an actual building situation. This is the sulfur factory, and you can see that there is an attention to detail, right? It is actually a pretty slickly detailed shed, even though it's relatively simple. And the structural principle and the materials, again, kind of allowed to speak for themselves. Not really, nothing is hidden. The detailing is thoughtful enough so that there is a clarity of the idea, a clarity of the structure, but there is no sort of aesthetic beyond that, right? Piano is interested in the material, he's interested in the fabrication process, and he thinks that is enough to kind of speak for itself. In the late 60s, Piano goes to London to sit in on a conference on lightweight structures. And he meets Richard Rogers there. Team 4 is dissolving by kind of mutual agreement. Rogers is looking for a new design partner. He and Piano hit it off. Rogers, again, from a family that is half Italian, so they have that in common. But more importantly, they're both interested in lightweight structures and in demountable structures. And the two of them in 1971 enter a competition for the Pompidou Center in Paris. And this is a huge commission, a giant art museum on the site of the old Parisian, part of the old Parisian market. And everyone expects that it's going to go to kind of a big name architect. And as we saw, the jury included Jean Prouvé. And it's my hunch that Prouvé looked at this and thought, well, this is clearly the kind of wave of the future. There's not much to their original entry. It's basically this giant three-dimensional space frame with mostly graphics, escalators flying from floor to floor, the sort of standard issue space age radar dishes and things on the roof, and things like LED ribbons and screens that are designed to show that what they want to provide as a museum is not necessarily a monument, but rather a kind of demountable structure that can change as the artistic moods kind of change, right? And in particular, they foresee a structure that can support the kind of electronic art that they see as being the kind of wave of the future. This is post-1968. There's an idea that society is changing so rapidly that you can't really predict what the sort of cultural moves are going to be next. Pop art and pop music and these things have entered the scene and are seen by some as legitimate art forms, seen by others as absolutely not. And so this is a really radical scheme that says that instead of the monumental museum, what Paris needs is a sort of scaffold that can adapt to whatever the changes in art are going forward. They, very surprisingly, win. They partner with Ove Arup, who are the structural engineers who are going to come in and kind of turn this into a buildable structure. And the iconic building that they end up doing is both incredibly controversial and also has a kind of lasting legacy, right? Still a vital part of the Parisian landscape today. There are things about it that carry over from the competition. So you can see that the structure is composed of these very, very long span trusses. And the idea there is that the floors can be changed around at will, that there aren't a lot of columns or shear walls or anything that are impeding the way the galleries are laid out. On the left, you can see that the mechanical systems all come in from one side of the building. They feed the galleries on a very tight grid that allows for individual rooms to be changed out without having to go in and change the ductwork around. And on the right, you see the kind of forecourt, the front door, if you like, of the museum, where the main elevation is going to be this giant escalator that brings people up to the top and lets them work their way down through the various galleries. There are ideas initially about all of these trusses being able to move up and down to open up double height spaces or not. In the end, none of that happens. The trusses are fixed and the galleries actually do get changed around, but on a much longer timescale than anyone foresees. It is in a way a kind of monumental museum, just with a very, very different expression. If you look at the section, you can see that all of the mechanical systems are on the outside, and the escalator as well is on the outside. And it is really both an exoskeletal building and what we might call an exomechanical building. By turning the typical museum inside out, Rogers and Piano provide these sort of pristine gallery floors with no interruptions. And at the same time, all the guts of the building form the aesthetics. And you can see here, this is looking the main plaza on the left, and you can see the escalator kind of crawling up the front of the building. And on the back, you see these four cooling towers that become the kind of icon of the building from the east. On the ends of the building, you can see the structure is expressed. You see very clearly the long span trusses, and you see the cantilever beams that counteract them, right? That provide a little negative moment that allow the trusses to span as far as they do. Those beams are kind of their own story, and Peter Rice, the engineer for Arups, who kind of masterminded this, wrote about these extensively. These they called them gerberettes, a French term that basically means a kind of long snout. And you can see here they are cast steel. You get a sense for the scale of each one of these by looking here at this steel worker in the back. They had to be engineered, as you see on the left, to save as much weight as possible. They're enormously heavy. And the problem that Rice faced was, how do you get these very, very heavy steel elements through the streets of Paris in one piece to the job site? And so they're trying to save as much weight as they can. You can see that they are good cantilevered shapes. They taper from the root out to the edge. And then if you look at the cross sections, you can see that in cross section they're basically giant I-beams, right? They have flanges top and bottom, webs in the middle that are narrow, and they sort of flare out around the root. So the material is really being put exactly where it's needed. This is still an analog process, but you begin to see some of the geometry in the upper left of the drawing, using things like plotting points, projective geometry, things that are starting to anticipate the role of the computer coming in to design. Here, one of the long span trusses being hoisted into place. And as you see here, being laid onto its rocker joint on the back of the gerberette. In the front of the gerberette, there's a tension rod that holds it down. So there's a little bit of leverage that's, again, putting that negative moment onto the joint to begin with. All of this stuff is fascinating to Rogers and Piano, the way it's assembled, the fidelity to static form of the gerberettes, and in particular, the amount of ductwork and piping and services that it takes to make an art museum go. And so again, they're very willing to put all of this on the outside, to let it speak for itself, to let the ductwork and the structure basically be the building elevation, right? All of the kind of polish is on the interior. On the exterior, again, there's a frankness about how the building actually works, right? Not trying to hide anything, even to the extent of not building the brick towers that Kahn would have clearly clad all of these ducts in. Rogers and Piano think getting rid of the brick jackets and instead just showing off the technology is a better way to go. Here you can see this amazing public plaza in front. And then that escalator, which remains to this day one of Paris's top tourist attractions, right? The view from the top draws people on its own, right? Whether you're interested in what's going on in the galleries or not. There's clearly a kind of space age aesthetic to this, right? It looks like a gantry from Cape Canaveral or something. The escalators feel like, you're maybe ascending up to some kind of space station. All of that is very maybe subliminal, but certainly not unintentional. And sort of ironically, once you get inside, the Pompidou's curators have tended to treat the building like a normal museum, right? So even though, as you see on the left, there is all of this very, very fine-grained ductwork that lets them sort of move the walls around on a regular basis, it's never quite happened. And the building has essentially been treated as a set of fixed galleries almost ever since. Nevertheless, enormously successful, and it certainly launches Piano's career and Rogers' career. They work together off and on a little bit, but generally sort of go their own ways. And it has an enormous impact in the press, right? It is such a different building, such a kind of rejection. To some, it's a slap in the face of everything that makes Paris Paris. But it very quickly, like the Eiffel Tower, becomes a symbol of the city. And it's regularly one of these buildings that is the most loved and most hated building in Paris. It gets enormous press, though, and really sets the stage for what becomes this high-tech movement. Piano goes back to the idea of lightweight structures, and over the course of his early career, he designs a lot of pavilions like this. This is an exposition pavilion for IBM. IBM then manufacturing business machines early into the mainframe and personal computer business, looking for a pavilion that looks technologically fluent, right? That looks like the sort of level of performance that they're advertising for their machines. And you can see this is demountable. It's made of wood ribs and then plastic sheets that are vacuum formed into these pyramids. Again, the idea coming from Piano's early work in Kahn's office. Underneath the floor, which as you can see is just simple plywood with carpet tiles laid on top of it. Underneath that floor, there are packaged HVAC systems. So they can pick this up, take it apart, take it to wherever they're showing off their goods next. And as you can see on the right, all of that HVAC under the floor blows air in up against the plastic skin. Probably necessary, right, if you put the building out in the sun. And then you can see there's also a giant extract duct that runs along the top. Piano gets more and more interested in fixed buildings, though, and applying some of these ideas about lightweight structure, about expressive, not only structure, but expressive fabrication. And in his early built work, you can see that he is interested in showing off how the building works and how it's put together on a number of levels. To me, this is the sort of inverse of the IBM pavilion. This is a small office in Vicenza where Piano is interested in natural daylight. And so he builds this ceiling out of corrugated aluminum elements that you can see in the view on the right, that are going to bounce and diffuse not only the daylight, but the little bit of artificial light that he proposes for the interior. At the same time, the office is defined by these two sloping verticals, right? Vertical structural elements that resist the pull of that catenary roof in, right? Resist whatever little thrust that it has. These ideas about showing off the way the building's fabricated, the way the structure works, but also getting more and more interested, in Piano's case, in the role of daylighting, really come together in what to me is his kind of early masterwork, the Menil Collection, a small museum in Houston, Texas. Originally, back in the early 70s, this was a project that was supposed to go to Louis Kahn. But by the time the project really gets going, Kahn has died. He dies in 1974. And Piano is hired as someone who is seen as a kind of worthy successor to Kahn's tradition. It's in a suburban Houston neighborhood, so Piano has to keep the building small, and he chooses to make most of the building's exterior in this gray clapboard siding that rhymes kind of with the early 20th century houses around it. On the right, you can see the kind of porch of the building, and you see these light scoops, these white light scoops that are clearly the kind of building's signature. On the left, you see them more head-on. This is really the kind of fundamental module of the museum, and it's a really integrative piece that Piano borrows from the ferro cement that Nervi has used in the 50s and 60s. Here, though, he's making an element that's not only structural, but it is also the element that's going to carry the HVAC and to do the job of bringing daylight through the roof and scattering it on the museum floor in a way that won't damage the artwork. So a similar process or a similar function as the concrete shells in Kahn's Kimball Art Museum. Piano's sketch in the center, you can see that each one of these scoops is shaped not only to reflect light into the gallery, to bounce it in a couple of times so you get it very light, very diffused, but also you can see within the triangular supports there's room for ductwork that can blow air up against the glass roof that goes overhead. And these fins are actually carrying the glass above them, right? So they are structural, they are housing the mechanical, and they are also doing the job of illuminating the interior. And Piano, once he's solved the problem, right, that module gets deployed kind of relentlessly throughout the galleries. And I think, interestingly, it comes out of the building and becomes the signature on that front porch. So there's no need necessarily for the kind of complex geometry of bouncing light around on the front porch. But Piano thinks that it's important enough to explain kind of how the building works that this is the first thing you see when you come up to it, right? That it's a kind of offering, a kind of explanation of the building's fundamental module. On the inside, you can see that this works really well, right? This is a gallery that has sculpture in it, so there are also vertical windows that bring in side light, which is good for seeing sculpture in. But you can see the effect of the daylight ceiling on the far wall, right, where there's this kind of very, very even cast of diffused, very, very moderated daylight. You can see also that the scoops have a track in them, so the artificial light is coordinated with the daylighting as well. And this idea of using natural light in galleries becomes one of Piano's trademarks. He becomes as interested in that as he is in the appearance or the explanation of the fabrication and the structural processes. And to me, most interestingly, these two buildings also in Texas, the Cy Twombly Gallery, which is right across the street from the Menil, which uses this layered system to bring in diffused daylight and then to scatter it using a fabric as the gallery ceiling. So there's a layer of louvers, there's a layer of structures, there's another layer of structure that holds up the glass, and underneath that glass there is another frame that holds a second set of louvers, and then finally the fabric panel. All of them kind of pull it apart in a way that lets Piano resolve all of the detailing. Most of this in this building, though, is hidden right by the fabric ceiling. More interesting, I think, maybe is the Nasher Museum, which he did in Dallas in 2004. Dallas, of course, just down the road from Fort Worth, so there, I think, is a clear nod to the Kimball here. And what's fascinating about this building is that the roof, the louvers on the roof are actually all compressed onto this aluminum screen, this perforated aluminum screen that you see in the photo on the right. The genius of the screen is that all of the perforations are conical. They're all made by a stretch forming process, and the cones all face due north. So even though what looks like a full spectrum of light is coming in, you're only ever getting blue sky light, right? The north-facing cones never let direct sunlight into the galleries below. And as you can see, the light is very, very soft, but you're seeing everything with against the background of this blue sky. When we come back, we'll look at the careers of Richard Rogers and then Norman Foster, and then look at the kind of legacy of the high-tech movement and how it moved on from the initial experiments that we'll discuss.